Hello everyone, today I am hereby to give a presentation on principle of operation of centrifugal compressors. And next I will give a small introduction of myself. My name is G. Sainath Reddy, having a pin number of 219558109. And now let us come into topic in the abstract. In this presentation, we will discuss about the working principle of centrifugal compressor with aid of diagrams. And along the centrifugal compressor, we will discuss some term related to centrifugal compressor so that we can able to understand the working principle of centrifugal compressor easily and accurately. So let's get into the topic. Introduction. As the name suggests, gas turbine engines compressors provide the compression part of the gas turbine engines, the thermodynamic cycle. As you know that as an aeronautical student, we can able to understand that a compressor is required in combustion to produce the amount of thrust to produce the amount of thrust which tends the aeroplane, which tends the plane to move further to overcome the drag. Next, there are two basic categories of gas turbine engine compressors. There are axial compressor and centrifugal compressor. So the gas turbine engines compressor further classified into two types. They are according to the compressor, they are classified into two types. They are axial compressor and centrifugal compressor. So and my topic is belongs to only centrifugal compressor. So I am hereby to give a presentation on centrifugal compressor, not about the axial compressor. Now let us first initially we should discuss the function of compressor, because the both compressor, axial and centrifugal compressor, main need is to describes now. The compressor section of the gas turbine engines has many functions. Its primary function is to supply air in sufficient quantity to satisfy the requirements of the combustion burner. Especially to fulfill its purpose, the compressor must increase the pressure of the mass of air received from the air inlet duct and then discharge it to the burner in the quantity and then the pressure required. By this point we can able to understand that the compressor is used for many purposes, but the primary purpose is to produce the air sufficiently, because as you know that the compressor which tends to pick the air and tends to move to a combustion chamber. As you know that for combustion chamber the air is much near in quantity, therefore the compressor primary function is to supply the sufficient amount of air with the help of a suction or anything processes, so that they can able to, so it can be achieved. And next, the secondary function of the compressor is to supply bleed air for various purposes in the engine and aircraft. The bleed air is taken from various pressure stages for it. And as we recently described the primary function of the compressor, now the secondary function is to supply the bleed air. Now as a students, you can come across a doubt, what is meant by bleed air? A bleed air is an air in which the compressor will compress the air and they will save for the specific purposes when the air quantity is not improperly balanced, then they will use this bleed air. And next, bleed air is used in various applications. Some of them are listed below, where it is used for cabin pressurization. The major is, as you know that the plane should move some specific distance from the ground. As you know that the air outside the fuselage possesses high pressure, and now we should able to balance the pressure inlet and outlet of the air. So therefore we will use the bleed air to balance the pressure. And next, it is used for de-icing and anti-icing equipment, which means, as you know that due to the atmospheric condition, the wing get freezing. So if it gets freezing, the aerodynamic properties of the wing may varying, which tends to crash or which tends to any damage. So therefore, to avoid this, we will use high pressurized air, which will slice out the ice formed over the surface. And next, which is used in pneumatic starting of engines. Next, centrifugal compressors. Now let's get into topic. Principle of operation. The centrifugal compressor consists essentially of a stationary casing containing a rotating impeller which imparts at high velocity to the air a number of fixed diverging passes in air in which the air is decelerated and consequently raises the static pressure. And next, the lateral process of a diffusion and consequently the part of the compressor containing the divergent passing is known as the diffuser. Air is sucked into the impeller eye and whirled around at high speed by the vanes on the impeller disc. At any point in the flow of air to the impeller, the centripetal oscillation is obtained by the pressure rate, so that the static pressure of the air increases. The remainder of the air, static air race, is obtained in the diffuser, where the very high velocity of air leaving the impeller tip is reduced to somewhere in the region of the velocity with the eye to the tip of the impeller, which the velocity enters the impeller eye. The normal practice is to design the compressor so that about half the pressure race occurs in the impeller and half in diffuser. Now I will discuss about the topic in which in the centrifugal, as you know that the pressure will be increased. That means in which it consists of two components called starter and rotor. First, starter. As you know that the free stream velocity, the free stream air possesses two components. One is pressure and one is static pressure and second is kinetic energy. As you know that first initially in the starter it tends to increase the both. Now we should need only static pressure. It does not have use of kinetic pressure, kinetic energy. Therefore, in the starter, the both will be increased. The starter, due to the motion provided by the compressor, the static pressure and the kinetic pressure will be increased. Then, after increasing it, and then in the impeller means in which it consists, in which it also known as rotor, in which it has a stationary vanes in which the kinetic pressure of the air will comes contact to a stationary vanes, which tends to convert the kinetic pressure of an air into the static pressure, so that we can able to get increase in pressure. By the end of this, we can able to understand that the pressurization in the compressor is carried in the two ways. One, it is the half of the pressurization is done in the starter and the second half is done in the impeller. Now if we observe the figure in which it can able to understand that in which we can able to understand here the width of a diffuser and then the impeller eye, in which first the suction air is carried to the impeller with the tip in the impeller eye, and which it tends to the impeller, and as by the end of this operation we can able to get the pressurized air. Now it is a centrifugal. In this figure we can able to understand this is in which the initial the position starting with the is called starter, which tends to increase the both pressures, and then the impeller means in which it consists of a divergent section. Due to a divergent section, in between we will place an in a stationary component in which and when it comes into contact to it, and it tends to lose its kinetic pressure, and which it converts into a pressure, static pressure. Conclusion. By this presentation, we had discussed the working principle of centrifugal compressor and function of a compressor. Next, the centrifugal compressor consists essentially of a stationary casing containing a rotating impeller which imparts a high velocity to the air. So this is the end of the conclusion, end of the presentation. In this presentation, we will came across the working principle of the centrifugal compressor, and we can able to understand now as a student we can able to understand what is the main purpose of centrifugal compressor, or what is the main purpose of compressor, and what are the phase we will going to come across during the compression, during the compression of increasing pressure of it is discussed in this presentation. So thank you.